Hi, welcome to part 6 of electromagnetic induction. In this video, I shall explain the solution of question number 6.4 given in page 230 of your NCERT Physics Part 1. So please turn to page 230 of your book so that you have a better understanding, even though I would be explaining the question before giving the solution. So the question number 6.4 says there is a rectangular loop of sides 8 cm and 2 cm which is kept in a magnetic field of strength 0.3 Tesla, which is normal to the plane of the loop, and this loop is now being pulled out with a velocity of 1 cm per second. So what would be the EMF induced in the loop? So part A says that it is being pulled out in a direction normal to the longer side of the loop. We know that as long as the whole loop is inside the magnetic field, there will not be any change in the flux linked with the loop. Hence, the induced EMF will be equal to 0. EMF starts getting induced as soon as the arm AB of the loop starts leaving the magnetic field, and it lasts till the arm CD of the loop leaves the magnetic field. And again, when the whole loop is outside the magnetic field, there won't be any EMF as the flux linked there won't be any change in the flux linked with the coil. Now, as the loop is getting pulled out with a velocity of 1 cm per second, that means in every 1 second, 1 centimeter of the loop is coming out of the magnetic field. So initially the EMF starts getting induced when the arm AB starts leaving the magnetic field. After 1 second, 1 centimeter of the loop will be out of the magnetic field. So the area that will contain the magnetic flux is only given by this. That is CD A dash B dash. So this area has now reduced. But we see that the length of the area that contains the magnetic flux remains the same, that is at 8 cm. But the breadth of the area that contains the magnetic field after 1 second has reduced. So the breadth is changing at the rate of dB dt, that is 1 centimeter in 1 second. It is at this rate it is decreasing. 1 centimeter per second can also be equal to 1 into 10 to the power minus 2 meter per second. So, since we know that induced EMF is due to change in magnetic flux, and flux is equal to B dot A. So it is equal to BA cos theta. In this case, the magnetic field is perpendicular to the coil, and this is the coil, and the magnetic field is perpendicular to the coil, and the area vector is also perpendicular to the coil. That shows that between B and A, theta is equal to 0, hence cos theta is equal to 1. So flux can be written as B into A. Now, the change in flux d phi dt could be due to dB dt or due to dA dt, because phi is equal to B into A. Theta is not changing, it is equal to 0 because you are not rotating the coil, so there is no change in theta. There is no change in dB as well. This also is equal to 0 because the magnetic field is uniform. So definitely d phi dt is only due to change in area. Now induced EMF can now be written as being equal to d phi dt, which is equal to B into dA dt. Now since this coil is being pulled out in this direction, so as we have seen in the previous page that the length remains constant, so we can take the length outside and write dB dt. So this becomes equal to BL into velocity, that is the rate of change of breadth, which is nothing but equal to the velocity. If we put the value of B as 0.3 and length as 8 by 100 and velocity as 1 by 100, we get 2.4 into 10 to the power minus 4 is your volts, is your induced EMF. Now, as I said before, EMF starts getting induced as soon as the arm AB of the loop starts leaving the magnetic field, and it lasts as long as the arm CD is also it will last till the arm CD leaves the magnetic field. So till the loop covers a distance of 2 centimeter, because it starts at this point and ends at this point. At the moment the arm CD of the loop starts leaving the magnetic field, so till then the EMF will last. So if 1 centimeter is covered in 1 second, 2 centimeter will be covered in 2 seconds. So the EMF lasts only for 2 seconds. The next part of the question says that the same rectangular loop is now pulled in this direction, perpendicular to the shorter side of the loop. So again EMF will start getting induced in the loop only when the arm CB of the loop starts leaving the magnetic field, and will last till arm AD leaves the magnetic field. So it will start when arm CB starts leaving the magnetic field and will last till the point arm AD leaves the magnetic field. So as this loop is pulled out in this direction, the breadth remains constant at 2 centimeter, but the length keeps on reducing. The length of the area that encloses the magnetic flux. So to start with, the entire area was enclosing the flux. But as soon as the arm CB starts leaving the magnetic field, EMF starts getting induced because the area enclosing the flux starts decreasing. So after 1 second, it is only this area which is enclosing the flux, and this area has reduced. So now we can see that breadth is remaining constant while the area has reduced. You can see that the breadth does not change, but the length of the area enclosing the flux changes at the rate of dl dt, that is 1 centimeter per second, which is also 1 into 10 to the power minus 2 meter per second. So dl dt is changing at the rate of it's the rate of change of length is equal to the velocity. So again, induced EMF is nothing but d phi by dt, which is equal to B into dA dt. Again, theta is equal to 0, cos theta is equal to 1. So phi is equal to BA cos theta, which is equal to BA. D phi dt is equal to B into dA dt. So that's what we have written over here. Again, in the area we see that the breadth does not change. So we can keep the breadth out and write dl dt. And dl dt is nothing but again the velocity, the rate of change. Every 1 second, 1 centimeter will be out of the loop. Again, in the next 1 second, this part will be out of the magnetic field. Again, in 1 second, this part of the loop will be out of the magnetic field. So the rate of change of length is also equal to the velocity, which is B and V is the induced EMF. Now putting the values of B as 0.3 into breadth remaining constant at 2 by 100 into 1 by 100. So we get 0.6 into 10 to the power minus 4 volts as the induced EMF. And again we see that EMF starts getting induced as soon as the arm BC of the loop starts leaving the magnetic field and lasts till the arm AD leaves the magnetic field. So it will last till this loop covers a distance of 8 centimeter. So 1 centimeter is covered in 1 second, 8 centimeters covered in 8 seconds. So EMF will last for 8 seconds in this case. In case of any doubts, please log on to www.olympiadtester.com/mentor. Thank you.